Hi, I'm ED-SKaR, and today I want to talk about parallax, which is just a fancy word for saying how things line up. So this is of course an important factor when it comes to looking at various types of scopes, be it red dot scopes like these, or magnified optics, or indeed iron sights as well, like the ones I made for the Hurricane. But how the reticule, or your view through it, behaves is related to just how good the scope in question is. So first of all, let's have a look at what parallax is, and then let's have a look at these and see how good or bad the parallax is in them. And if I was a proper YouTuber, I'd have an introduction right here, but I'm not, so I don't. So as I mentioned at the beginning, parallax is a fancy name for how things line up. So for example, if you were going to aim at poor little Snorlax over there, you would have your eye, or in this case, the camera, the target, in this case, Snorlax, and then you would line up the front and rear sight, like so, and then you'd be ready to pull the trigger. So what you're doing in aiming is lining up four separate things. You want to have the view to the target that you have to line everything up with. So the first point of reference is your eye. The target is, of course, the last point of reference. And then you need 2 points of reference on the gun so that it is actually pointing parallel to your line of sight. If I was to only consider my front sight, then I could do the same thing there, and now the camera, the front sight, and the Snorlax are lined up. However, that's clearly not pointed even remotely close to the right direction, because while we've got 1 point of reference, we actually need more than 1 point of reference, so we need the rear sight as well, and only then is it pointed in the right direction. So a red dot sight works sort of similar, but also not really. So in the case of a cheap red dot sight like this, and actually my airsoft one as well is not a particularly good one, to aim at the Snorlax there, we're again lining up from the camera to the target, but we now have this red dot, which is horribly blooming because lighting is terrible in here. And we can line it up with the target there. However, with the same way as only looking at the front sight, if I twist this to the side, like so, I can still see the dot, and I can still see that the dot is on the target there. However, the angle that that's at is quite clearly pointed up here somewhere and not actually on the target. So in the case of the geometry of the lenses in this, it's not particularly good at giving that second point of reference. And if you put the red dot in the center of that hood and then line up the dot with the target, then you've got your 4 points of reference. Your eye, the target, the dot, and the middle of the hood, which is not ideal. So let's have a look at this airsoft red dot sight and see if that does any better. And this actually has brightness settings, so I can just adjust that to where it's a little bit easier to read. So here you can actually see the difference between the Nerf scope and the airsoft one here, because that reticule is moving around a lot more. It's a lot more finicky and it's bouncing around. And while at first you think that's a bad thing, that's actually very much a good thing, because that is reflecting, literally reflecting, the movement of my hand. So here, if I draw the dot around the edge of the hood, you can see that the sight itself is moving quite a lot. It's moving to the sides and up and down to the point where it's way off of the target. With this, if I do the same thing and draw the red dot, or the reticule in this case, around the edge of the hood, you can see that that's not moving anywhere near as much. Now it is moving, and the edges of movement are pushing the sight out of line with the target, so you would have a missed shot. So why is that behaving so much differently from this, if they have basically the same design? And the difference is that the lenses in here aren't lenses. They are simple flat pieces of glass, and what you are seeing there is simply a straight reflection of the LED that's in the kind of the base here. And because you have the reflection of the LED that's here in the lens that's here, it's equivalent to looking at something that's there. And what that means is that in a similar way to when you have just the front sight of the worker hurricane, it's almost like I just have the single position of the red dot here, but that I have to find it in the hood and line it up with the middle. The lenses on this, on the other hand, are actually lenses, and you can see a reflection of all of the rest of my room. Marvellous. So how is having a lens different? Well, just like in a telescopic sight or a magnifying glass, you can change the size that something appears, or in mathematical terms, how far away it appears. That's not really how it works, but just to explain how the sights work, I'm kind of going to go with that kind of dumbed down explanation. So in the case of this, we still have an LED that's physically down at the bottom here. Instead of appearing kind of here, it actually appears much further forwards because the warped reflection makes it appear further away. And mathematically, because it appears further away, but it's still physically mounted inside the sight, as we move the sight, the reticule appears to move more when we move the scope the same distance in comparison to the Nerf one. So on a real red dot sight built for firearms, the geometry in that is so much better than in this, to the point where it mathematically approaches infinity. And so the line of your sight and the appearance of the reticule appear in such a way that it approaches parallel, which is of course what you want. You want to line up your barrel and you want to line up your aiming as close as possible. So telescopic scopes will also work in a similar but also slightly different way. So here we have the obelisk reticule of the SUSAT. This is of course an airsoft replica, not a real one. And I'm having to hold the scope in exactly the right place because we have a supposedly 4 times magnification, but I don't think it really is exactly 4 times. Now, because we have a zoomed in view because of the magnification of the scope, the point of the obelisk is actually moving around an awful lot, and we can see that clearly. Now, in the case of both of the red dots, they were moving around just as much as this, but it was not as easy to see because it was not magnified like this. So as you see, if I go around like this, and oh, look, that's the recording light. If I move it around like this, the furthest that I can get away from the target is actually very small, but I am moving the scope around. What that means is that as I move the angle that the scope is pointed at, and therefore the barrel of whatever this scope is mounted onto, the reticule moves. And doing this in reverse is extremely difficult. So the way that this works is the lenses of the zoom part of the scope have a focal point, and on that focal point you have the physical part of what that reticule is. In some cases it will be 2 wires or hairs draped across, and that's where the term crosshairs come from. Often it will be painted or printed onto a non-magnified piece of glass, not a lens, just a straight flat piece of glass. And I believe that's the case in this one because of the shape of the reticule. Oh, I've lost it. Oh, there it is. Back. There we go. What that means in terms of parallax is that it has a very narrow movement and inaccuracy. And you would expect that most people looking through it would line up so that the center of the reticule is in the center of the sight, rather than like this, for example, where it's not lined up. So you line up your eye, you line up the target, you line up the post, and as long as it's roughly centered in sort of the middle of the scope's view, then your parallax will be, in theory, ideal. So you really do have to be lined up with the axis of the scope to even be able to see through it. So let's compare that to the long shot scope. Okay, there's no lenses. That's just, yeah, forget that. Never mind. So what's the easy way of comparing them? And that's actually something that I've been trying to get people to do in reviews of scopes for quite a while. So because you need to line up the target, the LED, the reflection of the LED, the lens, and your eye, how can you reduce the movement as much as possible to just test the parallax? Well, if we put the scope down on a flat surface and leave it there, then we can make a target that doesn't move, and we've got the 2 points of reference of the scope that don't move, whether it's the reticule and the focal point, or whether it's the lens and the reflection of the LED. And then we can just move the camera and we can see how the dot or reticule moves on the target. So what we would ideally like to see is, because the scope is pointed directly at the target and the scope isn't moving and the target isn't moving, we would always want to see that the indication of where your shot will land is still on the target. So as we move the camera around, we want to see that dot move in relation to the camera's movement so that the dot stays on the target, because the scope hasn't moved, the barrel lined up with the scope hasn't moved. What we will likely see, particularly with the red dots, is we'll see some movement. And in the case of something like a square like these, or a round one, we will be able to draw that shape around the target with the view of the reticule. And we should be able to do a similar type of thing with a magnified optic. However, it's much more difficult to actually get a camera view of that. However, I'm still going to try. So here we have the small target that I've put on there, and we can see that that lines up if I line everything up. And like this, all 4 points do now line up correctly. However, if I was to move my eye, the dot now appears very far away from the target. And I can go up, left and right, and I can go down. I can draw this square all the way around the target. So while the scope hasn't moved, and therefore the barrel that the scope is attached to wouldn't have moved, the dot doesn't appear to be anywhere near the target, and therefore this scope is not particularly very good. Okay, it seems like that didn't record previously, so I'm re-recording it. Well, that's why the lighting's different. Apologies for the kind of discontinuity there. So there we can see the target, and looking sort of centrally, I can actually put the reticule right on the right hand edge of that target, if only it would focus. However, if I move to the very right hand side, you can see it's actually slightly inside the target, and if I move to the very left hand side, it's just off of the target. So the parallax in this is less than the size of that small piece of card. However, it is still significant, and if you were shooting at longer ranges, that would have quite some substantial effect. Given that this is only in the order of roughly 5 meters, it's not a problem. But if you were shooting at, say, 30 or 40, that might mean a missed target. And with the telescopic SUSAT scope, which we're getting a reasonably good view through, and as I move the camera, you can see the appearance of the reticule does actually still move, if only a little bit. So while this is a lot less movement than the Airsoft Red Dot, and a lot less movement than the Nerf one, that inaccuracy still exists. And that's the reason why parallax is important. So that's hopefully an understanding of parallax and how it works, and how to test it as well. So when I go around saying, test the parallax of this scope that you're reviewing, now you understand what I mean. Or at least if you're still awake after this far too long video. There is, of course, a lot of maths involved, and you can counter that by not doing any maths at all and just having a flat lens, doing some maths and getting a reasonable distance that the dot appears to be so that it sort of lines up. Or in the case of some very expensive and very good optics, you can actually do the maths just right and have it appear infinity distance away, which is a thing we can do with technology. However, I can't afford to own such things, so I've just tested the scopes that I do have access to. But with that far too complicated explanation aside, I'm ED-SKaR, always have been, and thank you very much for watching.